Welcome back. Today we're going to be talking about the probability of compound events. So, whenever we have independent events, the probability of A occurring and then B occurring is probability of A times probability of B. When the events are dependent events, then the formula is different. But today we're only going to be talking about independent events, meaning events that where the outcome of one doesn't impact the outcome of the other. So, for example, if I roll a die and I get a six, does that change the probability of rolling a six the next time? Well, no, it doesn't. And so that would be an example of when this would work as an independent event. However, let's say that I draw a king from the deck and then I throw that card away. And then I want to know what's the probability of drawing a king again. Well, now there's one less king. So now it's a little bit less likely than it previously has been to draw another king because I threw one of them away. There's one less in the deck now. Today, we'll only be talking about independent events and we'll only be using this first formula here, where it's the probability of A and B together is the probability of A times the probability of B. And the probability in general, just as a reminder, is the number of favorable outcomes over the total number of outcomes, gives us the probability that event A will occur. So let's do two examples today. The first one says you roll one six-sided die twice. What is the probability of A rolling 5 both times and B rolling an odd number and then a 1? Okay, so for part A, first I need to find the probability of rolling A the first time, of rolling 5 the first time, and then the probability of rolling 5 the second time. So what's the probability of rolling 5 one time? Well, that would be 1 out of 6 because there's 6 possible outcomes, 1, 2, 3, 4, 5, 6, and there's only one favorable outcome because the only favorable outcome in this scenario is rolling a 5. So 1 out of 6 times, I will get that favorable outcome. And then after I rolled my first 5, I want to roll a 5 once again. So I'm going to multiply that by probability of rolling 6 the second or rolling a 5 rather the second try, which is also 1 out of 6. There's still 6 sides on this die and there's still only one favorable outcome. Then I'm going to multiply these fractions. So as a reminder, to multiply fractions, we multiply the numerators together to get the new numerator, and we also multiply the denominators together to get the new denominator. So 1 times 1 is 1, and 6 times 6, 36, and then we got it. All right, let's do example B. It says, what's the probability of rolling an odd number and then a 1? So first, we need to find the probability of rolling an odd number. Well, overall, the denominator is still the same. There's 6 possible outcomes. The outcomes are 1, 2, 3, 4, 5, and 6. And out of these, the odd numbers are 1, 3, and 5. And so therefore, 3 out of these 6 outcomes will be a favorable one. So the answer is 3 out of 6. Then, and it says for the second roll, we would have to roll a number 1. Now, how many ways are there to roll a 1 on a six-sided die? Only one way, which is to roll that one. And then there's 6 possible outcomes. So for that second one, there's just one possibility out of 6. Then once again, I'm just going to multiply the numerators to get the new numerator. So 3 times 1 is 3, 6 times 6, 36. And then if I divide by 3, I'm going to get 1 over 12 is the reduced form. Typically for probability, we don't care as much about reducing the fractions as we would in other topics, but still never a bad thing to reduce the fraction if we're able to. All right, let's try a second example. An urn has 3 marbles, 4 blue marbles, and 7 yellow marbles. If Sarah randomly draws 1 marble, puts it back, then draws a second, what's the probability of randomly drawing A, a blue marble and then a red marble, and B, a yellow marble both times? So for this one, the reason that this is a compound event where we're able to use this expression is because Sarah puts the marble back. So whatever she picks, she puts it back. And so we end up drawing from an urn with the same marbles in both tries. If it said that she took a marble out of the urn and then put it aside, or she threw it away or something like that, then that would change the question a little bit. So that's definitely something important to note in this question in particular that we're doing is that she puts the marble back into the urn after drawing it, because if she didn't, that would change which marbles were in the urn for the second draw. So let's start with part A. the probability of drawing a blue marble and then a red marble. So first I need to know what's the probability of drawing a blue marble. Well, there's 4 blue marbles out of a total of, well, let's see, 3 plus 4 plus 7 is going to be 14. So therefore, there's 14 marbles total. So the probability of drawing a blue marble is 4 over 14. Then, what's the probability of drawing a red marble? Well, that would be 3 out of 14. And so I'm going to multiply it by 3 over 14. So now I'm going to multiply the numerators and the denominators and see what we end up with. So let's see, 3 times 4 would be 12. So we're going to get 12. And then 14 times 14 is 196. And then if I divide both of those by 2, I get 6 over 98. And then if I divide both those by 2 again, I get 3 over 49. And so therefore the most reduced version of the answer is 3 out of 49. And that's pretty close to 0, so this isn't very likely to occur. It's more likely that something different will happen other than the blue marble and then the red marble occurring. The second part, part B, asks us the probability of drawing a yellow marble both times. So first, I'm going to find the probability of drawing the yellow marble on the first try. Well, there's 7 yellow marbles and 14 marbles in all, so it would be 7 over 14. Then what about drawing it the second time? Well, it would be the same 7 over 14 once again, and the reason being is because we put the marble back. So although we would have to get a yellow marble in the first place, it ends up going back in, and so we draw from an urn with the same number of marbles of each color of marbles, the second draw that we do. Now I'm going to actually, instead of just multiplying across, I'm going to notice that 7 over 14 is actually just 1/2. So this is the same as 1/2 times 1/2, which is 1/4. If you do multiply across, you'll still get that same answer, but there'll just be a lot more reducing to do in that scenario. So if you do notice that you're able to reduce earlier, that's also an option as well. All right, well, that is all for this one. As always, if you have any questions, feel free to put those down in the comment section, and we'll see you up for the next one.